on the 1/8 inch brass. I'm going to lay out the 3/8 inch connecting rod end. Here's the picture from the diagram that I blew up. You see it right here. It's not much to go by, but the piston's a 1/2 inch, so that's 3/8 I think. I don't know, 3/8 seemed like the right size. I sketched out a diagram of it. It's going to have an 1/8 inch hole in the middle. It's 1/8 inch wide, 3/8 by 3/8, with a 1/16 hole in the top. I'm going to turn the end of the connecting rod down a 1/16 to just slide in there, and then I'll solder it. So I'll set this at 3/8. That's 375. Strike a line. Now when I cut this on the bandsaw, I'm going to save the line, so then I can file it right to the line. Alright, so now I've got 3/8 inch by 3/8 inch square. Now I've got to put the radius of the little bottom piece. This is for the connecting rod end. I've marked out 2 of these, and they have a little rounded bottom. Then they're going to have a 1/8 inch hole. I'm going to ream that hole. So right now I'm going to center drill, and then drill undersize, and then ream the hole for the crank pin. So the first thing, I've set this on parallels in the vise. Small center drill in the mill drill chuck. I use my mill a lot for a drill press because it's accurate. I put punch marks in there with a tiny punch. And I haven't cut this off yet because this gives me something to grip. It's a tiny part, 3/8 by 3/8. Very hard to hold that with anything. So before I cut it off the material here, I'm going to do as many operations as I can while I can still hold on to a big chunk of it. But just tap it while it's running, see where it hits. And I'm going to look in there real close and see if it's right where I want it, and it is. Alright, that's just the center hole. That. Okay, so now I've got a 1/8 inch is 125. So I'm going to drill 120 thou. Drill bits usually go over a little bit. And then I have a reamer. I have an 1/8 inch reamer. So after I drill it out close to 1/8, I'm going to ream it to exactly 1/8. You can get these reamers at 124, a thou under and a thou over. If you're doing really precise work and you drill it exactly 1/8 and you have a 1/8 inch shaft, that's going to be a really tight fit if it moves at all. If you go a thou over, your part will fit. The shaft will fit in the hole. Reamer's a bit longer than an ordinary drill bit. Alright, reaming this out now, 1/8 inch. That's it. That was easy. I should have about an 1/8 inch hole, and before I remove this, I'm going to check it. Yeah, that's beautiful. That's beautiful. I have to deburr these on the back and then cut these off. Okay, I have it cut off now. I spent the last 15 minutes looking around in the swarf because I wasn't careful, and when this cut off it jumped and went down into the netherworld of the swarf. Luckily, I found it by the foot of the bandsaw, so that's kind of frustrating. All work stops when you lose your tiny part. Anyway, you can see the lines there, and I've got to bring it down. Now, I'm going to use the belt sander, and it's going to get very hot because brass is a great conductor of heat. So what I'm going to do is I'm going to clamp this in the vice grips. Now, I have these vice grips that have smooth jaws, so they don't rip up the part with that. You know, the normal jaws of pliers or vice grips are serrated for grip. That will tear up your screw heads and your part. So, see those smooth jaws? So I'm going to hold it like that and bring it down to the line. That looks pretty good. You can see I just went right down to the line that I marked out on the surface plate. Okay, I'm back over at the workbench now, and I've got some of the parts laid out for the two engines. What I'm working on now is the big end of the connecting rod. From this piece of 1/8 inch brass, I cut out this big end. Before I cut out the second one, I want to see how the first one turns out. It's looking pretty good. I just need to clean it up. So I have a nice little fine file here, and I think all my files are overdue for a serious cleanup. I'm just going to take the burrs off and clean it up. Now, the next operation on this will be, I'm going to drill a 1/16 inch hole in the center, and then I will turn down the crankshaft itself, fit it in the 1/16 inch hole, and solder it in place. Again, I'm building this exactly as the picture in the drawing I have from Vic Smead's book. See how it looks after we get it all set up on the engine and most of the burrs off. So the next thing is to mark the center line. I'll do that with the height gauge here. Color it in first with the Sharpie. That way I don't have to wait as long for that red Dykem to dry and get there all over my hand. Alright, so I'll just lay it on here. I'll measure its actual width, divide that by 2. So half of 126.063. Now, to check it, flip it over. Make another line. And if it wasn't in the center, you're going to get 2 lines. But then the center is in between those. When I flipped it, I got a thick line. Then I find the center this way, the 3/8 point, and mark it again. Half of 3/8 .187. Now I've got a nice little crossroads that my sensitive punch will find. I've got my little tiny palm grin here. These things are great. The beautiful part about these little palm grins is you can lay it on its side, you can lay it up like this. It's 90 degrees. It's ground flat and 90 on each side. So, boy, if you're doing a part, you can lay it like that. You can lay it like this. So, I use it in my manual tap machine to hold parts. But right now, it's going to be great for this. So you follow along the line. Let the feel of your fingers and the tip of the point follow along that line. And when you hit cross line, the center line, it'll just stop. You hardly even have to look, and you can do it very quickly, and it'll be dead on. Now I can go to a little bit larger punch. Still very small. Wham, this one pretty good because it's hardened. I don't know if you can see that. Man, that's dead on. That's finished. So the next job on this is to drill it. When I get the hole drilled, I will machine the bottom of the crankshaft here to match the hole. Okay, I'm back over at the mill. Got the smallest center drill I have on hand at the moment. I wish I had my Sherline mill set up. This little part here, you could build the whole engine, this whole engine on a Sherline. And I'm going to drill that 16th. Okay, I've got the 16th inch drill bit. There we go. Nice. Notice I have the little palm ring clamped in my vise. That's all right. So I have a number 48 drill, 0.076. It's a little bigger. That's going to be easier to machine on the lathe, on the crankshaft, steel crankshaft. A 16th is really hard to get to, without breaking it off or bending it. So I'm going to go with this number 48, 076 drill. I think it's better. And it would follow the hole anyway, but there we go. That's done. That'll just give me a little bit bigger shaft to put in there. And that looks pretty good. That's, at least it's on the center this way and this way. Okay, I've got the connecting rod in the lathe. I had a little difficulty. First one I tried, grabbed the tool bit. This is the second one I tried. Same thing. So I'm like, I'm doing this wrong. I reground the tool bit. Very gingerly, I pushed it in as far as it would go. I think I've got it pretty close now. To be a tight slip fit. So I've got to take off a little. Let's get the mic on it. Let's see what. Yeah, 80. So I got 4/1000 to take off. I really want to leave maybe a half a thou in there because I want it to be a tight fit. Might do that with a file. That may be cutting or maybe not. I don't think so. We are very close. I think I got it that time. I think I got it. Felt it. Hope I didn't go too far. Alright, I can take it the rest. That's close. I'm going to take it the rest of the way with a file, and I don't want to go too far. I'm going to use the square one, or the triangle. That. That's a good fit. Connecting rod. That came out pretty good. I'm happy with that. That'll solder real nice. This is the connecting rod and the big rod, rod big end. Which the rod big end, you saw me making those, and I'm cleaning them with denatured alcohol. So I got these pretty clean with the alcohol. When you're soldering, you really want your metal to be as clean as possible. Let's turn that off. As clean as possible. Got some flux here. It seems to be working okay. This is Paste Flux Linux general purpose soldering, and I got a toothpick. I mean, you don't need much. I probably have too much on there already. So I'm putting the flux on, putting the rod in there with the flux on it and smearing it around. So wherever you don't want soldered, don't put flux. There's one and there's two. Alright, so they're cleaned, fluxed, and next is the solder. And I'm going to use this really thin solder. It's super thin, so you just don't use too much. Ignition. I'm watching that solder. You can see it start to boil. That's when you know you're getting probably too hot. I want to heat the steel and the brass at the same time. I want them to both get hot. That's hot. So you can see it's already gone. It's flowed. It's flowed right in there, just like it's supposed to. I probably ought to just leave that alone. Yeah, should have left it alone. I made a mess. While it's cooling, turn the brick around. Start on this one. I'm looking at the solder. The flux, and it's turning liquid. Let's give it a try. Yeah, that looks good. This one I'm not going to flip over. It looked like it flowed. So if it's going to work, it works really quick. Those are done. I'm just going to let them cool and go back to the piston.